my slide deck. Do you see my screen?
Yes.
Yes. All right. Welcome. So welcome to this webinar once again. I would like to welcome the members of i-moutier, but also the associated members, the guests, and of course the speakers. A very warm welcome from my side. My name is Fabian Käser. I'm a project manager at i-moutier. And welcome to this webinar on cognitive digital twins in manufacturing. I would like to ask you also to mute your microphones during the presentations. You will have the opportunity to ask questions right after the presentations. We will do first the two presentations, and then we will have questions and answers, but also the discussions later on, where you are invited to participate and to play an active role. Who we are, who is i-moutier? i-moutier is an incubator, which is a private association. We have an orientation in machine tools and precision industry, and we are focused on vertical value chains. That's in fact the manufacturers of machine tools, where we intend to help them on developing projects which are joint projects upon their needs they have, and of course also related to their suppliers and to their access to the market, to the customers. What we do in i-moutier is mainly two things at the moment. It's the animation and the stimulation of the ecosystems, the actors in the field of machine tools and precision industry, and especially in the region of Arc-sur-Bastien. But this is not limited only to this region. And in the future, we also intend to build a living lab dedicated to our activities. Who am I? Who is the speaker or the moderator of today? My name is Fabian Käser. I'm a project manager at i-moutier. Beside of that, I'm also a coach at Platin, a mentor at InnoSwiss, and my focus, my professional focus is supporting, coaching small and medium-sized enterprises, especially in the precision industry activities in this sector. I help companies to diversify themselves, to set up strategies, how to position themselves in the future. It deals a lot with business architecture, and also one of my specialities is build up collaborations between the companies, but also with academic actors. So why do we organize this webinar on cognitive digital twins in manufacturing? So we have the ambition at i-moutier to help the companies in the machine tools sectors to do also the digital transformation. This is a very important aspect to help these companies to position themselves to the future. So setting up a flagship project, that was a call from InnoSwiss. The idea is to do systemic innovation and to help the sector to innovate to the future. So our ambition is, especially if it comes to the machine tool sector, because you know today and since generations, the machine tool sectors was always one transaction of a machine, and here I exaggerate a little bit, then you hear nothing from your customers for 30 years, but because the machine is an outstanding quality, they will not fail. And it's always a transaction, it's a CapEx transaction. And that's this business model, this has to be changed in the future, because we have to think about what will be the value of the future. Is it the machine? I don't think so. What will be then the value of the future? We think that it will be services in the future. So it will be also thanks to industrial IoT, thanks to other digital capabilities, there will be also a shift in the business model from CapEx to OpEx, operational expenditures, to services. where we also are focused on customer centricity, on customer relation, these kind of things. And with the flagship project, we intend to stimulate the ecosystem, the actors in the field of machine tools, but also to bring them ideas, to bring them creativity. So what will be the future value? So our intention is, beside of that, to create a virtual sandbox where we can test concepts, test ideas, and then the hurdles are much lower to implement them in the real world further on. So what we would like to do is to ideate, to test concepts before they are implemented to the real world. And with this cognitive digital twins approach, we think that this is an excellent sandbox to test ideas, to test service ideas in the future. Why do we speak English today? As we are in Arc Jurassien, always we speak always French, of course, because we think the innovation will not only come from the sector itself, but we think also if we collaborate with other companies which are coming from other sectors like logistics, like energies, or other sectors, that could be also very stimulating, not only for our sector, but also for the other sectors. And for this, also the doors are open from our side to collaborate with actors from the other sectors. And that's why we speak English today, to attract companies and competence partners from other sectors. What are our other activities in i-moutier? We have several projects which are undergoing. Actually, we have the project Muse, which is a project to develop a central and secure update solution for embedded software in industrial machines and equipment, where we have 12 companies who are active in the project. We are very active also in the end-to-end innovation booster on microtechnology. This is a proof of concept platform where the actors in the field of microtechnology can submit ideas, where they can call for competences, call for partners, and then on the marketplace, the companies will decide if the idea is good, because they have to invest into the idea. At the moment, and that's the first loop which is undergoing right now, we have 7 ideas in competition. The first 2 have found already the amount which is necessary so that we can transform the idea into a project. So they found more than 5,000 Swiss francs from different companies, SMEs, but also academic actors. And once we have for each idea 5,000 Swiss francs from third parties, then we will transform the idea into a proof of concept project, where we will put also 20,000 Swiss francs from InnoSwiss, which is the sponsor of this initiative. And with this amount of money, we will do some small projects. It's very small amount of money and small projects, but it's a first step to test an idea, and it's a first step also to collaborate with other actors in the field. We have the project Charm, which is a project which is financed by the European community, and where we have our members Silvac and Tornos, who are collaborating with CSCM in the field of IoT, artificial intelligence, in harsh environments. And we have also the Jellypipe platform, which is a marketplace where we are actually active in the field of 3D printing, additive manufacturing, where people with ideas, they can submit their demand, and we do matchings with competence partners who can then realize the ideas, the parts you submit on the platform. So that's a short snapshot about our activities. One last thing before we start with the presentations is an outlook into August, where we plan to organize a roundtable dedicated to Swiss industrial platforms. What are the opportunities if industrial platforms will be in the future hosted in Switzerland as a Swiss platform, because you got the information certainly this week. Swiss Confederation will outsource its cloud to China and to the US, and I think we shouldn't do this, especially if it comes to industrial needs. And that's why we are thinking about what are the opportunities of industrial platforms hosted in Switzerland. It's not only about data hosting, it's also about hosting of services in the future, and that we would like to discuss with different actors in the field, movers and shakers, people who are experienced in that field, and you are warmly invited also to follow these discussions then in August. Let me introduce now the two speakers from EPFL Lausanne. We have Frédéric Dreyer Gonzalez. He's a colleague of mine. He's also a coach at Platine. He's also a mentor at InnoSwiss. So we often collaborate together. Frédéric is since 2020 a cluster manager on digitization and infrastructures and cities at EPFL. So he's very experienced in the field of digitization, in the field also digital twins. He has a background also in microtechnology, as he has been working on innovation and R&D at Officine Panerai and Swatch Group, and he was also the director in Geneva, OPI, Office de Promotion des Industries et des Technologies. He has a PhD in computational science from EPFL, and he has also an executive MBA from HEC Geneva. Before you start, Frédéric, I will also introduce Professor Dimitris Kiritsis. This is our main speaker of the webinar. Professor Kiritsis is since 2014 Professor for ICT for Sustainable Manufacturing at EPFL. He's a director of the doctoral program of robotics control and intelligent systems at EPFL, and he's also a full member at the European Academy for Industrial Management. So the overall goal of his research and his research group is the sustainable manufacturing to obtain a holistic view of product cycles in the manufacturing industry and to optimize the life cycle of manufacturing systems, products and services. And with this, I would like to hand over to Frédéric Dreyer for the first presentation, and then we will move directly to the main presentation of Professor Kiritsis. I quit my presentation and I invite Frédéric Dreyer to share his screen. Frédéric, the floor is yours.
Good morning, everybody, and thanks to be there. So, can you hear me properly? Yes. And can you see my screen? Perfect. In
Not
presentation.
Yet. Yes.
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 Perfect. Cool. So the goal of this presentation, more or less 10 minutes, is really to whet your appetite coming to the digital twins. So I will be more realistic on 30-60 degrees about the challenges around the Industry 4.0, Revolution 4.0, and so on. And I can see some people on the invited people there, quite also expert in this field of, I will say, digitalization. The idea of the presentation is really to be as a funnel effect, to be from large to some typical examples, and after to let the flow to Dimitrios for connective digital twins. So Revolution 4.0, or we can express that reconstructing the indestructible means that for me in Switzerland there is a huge I will say consortium of SMEs on representing more than 99% of the economy, and they need to move to this side of digitalization in order to not to survive, but to keep the line on, perhaps to move from a product to a services. As Fabian said at the beginning, the business model has to change on how we can use digital tools in order to be more and more efficient and to survive in this world of digitalization. I will try to show you a video. I love it from the World Economic Forum. It's really more on the what is the impact of digitalization of new technologies. On you after that, we will see what are the challenges for SMEs or industries around this 4.0 transition. stop in there because after it's really I how did I see the video? It's okay for everybody. Did you saw that properly with the sound or? Yes. Okay. Perfect.
Yeah.
So the key message is really important in this video. They show lots of things, but lots of technology. But the key message is that also collective intelligence, and it was also the introduction of Fabian linked to this initiative flagship from Innosuisse and so on. It's really important to have also different stakeholders around the table from the public and private sectors and academics in order to co-design all together on this transition from 0.0 transition with different impact. And there I will try just to bring some challenges as a level of SMEs, for example, or industries. There is, first of all, when we are talking about digitalization, there is some challenges around the organizations or the culture in your company. And we are not anymore on the waterfall organization. Now we need to be more agile and more lean. You will see that after in some slides that for me, the key message of digitalization is coming from the fact that we were centralized and digitalization will bring decentralization. So also the value creation driven is more important now than performance driven. And what is the experience for the customers, customer experience and so on. So it will change totally the organization of the company. And when we are talking about digitalization, we need to think about how we can reorganize our company around these technologies and what is the spirit. Hyperconnectivity is also really important, and there is a fast moving on new technology and constant changing in the market expectation of your customers also in from the industries and what they're expecting your customers and final customers. There is also an exponential progress of technology. You know, all the Moore's law saying that every 18 months some technology can be multiplied by 2 about the impacts, and there is more and more new technology on the market. Some will increase, some will decrease, but finally we need also to be very agile about these weak signals and to really perceive which technology will be very impactful in our own daily business on the organization. Use-based also economy is really important, and there is lots of competition on risk over data. As you will see after, data is really important, and also when we are talking about digital twins, we need to have a certain level of data, qualitative data, quantitative data. And as we know today, we are seeing that data is really the new petroleum of industries and the business. And the last but not the least, the hyper concentration of talents and so on. And again, ecosystem is really key, and it's really important to work in collective intelligence with local, I will say, actions with a global impact. So that's why i-moutier today is really the idea to meld different profiles around the table and to bring different kinds of stakeholders from the public and private sectors and academics in order to think and to co-create this kind of new solution. When we are talking about technology, we are talking about blockchain, we are talking about robotics, we are talking about AR, VR, mixed reality, and also the quantum computing. I just want to take 2 examples, but far from perhaps your daily business, but in medicines, previously and less today, the knowledge is not centralized with the doctors now. There is more and more use of artificial intelligence to make predictive or prescriptive decision linked to some data or information we can collect. And also we'll see in the future with the DNA and the powerful of the quantum technology, where we can make some predictive decision from our DNA-based combination. And another example is linked to the mobility. We can see that previously it was really important to have our own car. Now we are more in a sharing economy, and in the future there is some now project about this urban air mobility. And to give you an example, at the EPFL, we have a project with dozens of drones monitoring the congestion of the traffic and to make decision and predictive decision to simplify or to avoid traffic jam linked to the analysis of data and algorithm to do that. And it's kind of digital twins, and you will see in the end. Again, the key message that data is really important on your side as industrial. You have every day hundreds or dozens, millions data generated in your own business, and from that it's really fruitful to better understand how you can then. The opportunities of this transition is really on different pillars, but the first one is really on the lean management, on the new business you can bring also to your final customers, B2C or B2B. And digitalization will help you also to modify perhaps, or to think in another way what you can bring and what is your value proposition for your customer. And as Fabian says in introduction, it's more or less now more on the services. And there is lots of companies saying that I've got a product, but now the mindset is, oh yes, I've got a product, but I have to bring in services to my customers from this product. And also some impacts linked to the society 4.0. It's really important also to see what are the impacts for the society or sustainable development. You know, there is more and more first legislation, but this behavior, how I can be better for sustainable impact. Also, if I am a company in a tooling, machining, and so on. And the industry 4.0 is really one opportunity, means the new technology, and this new technology will bring new business, new product and services. And there is a big impact also on employability. And this is one of the key points of these 5 opportunities, the futures of the work or futures of work. Just to coming back to that, the key message I told you before, it's really the impact of digitalization is coming from decentralized production for conventional manufacturing, and linked to this digitalization, it totally now exploded, or it will decentralize the business. And we can now have, it's the example, for example, of the Micro 5. It's really to reduce the manufacturing size of the site, and perhaps it can be now more near the logistic point or the final customers. And linked to that, we can talk about the technology of robotics, of digitalization, 3D printing, artificial intelligence, or blockchain, and so on. All this technology together can help to coming from this centralized production mode to decentralized and to be more agile, for example, for the mass customized production. And one of the last points is linked to the data. So as we said, today we have tons of raw data, and one of the deal of the data science is really to collect this data, to make the creation, and to bring them all together in order to bring these blocks and to have predictive or prescriptive models. It's really on the data driven or use case driven. I've got a challenge, I have a problem on the market, how I can use this data in order to which kind of data I need to collect in order to have these predictive and prescriptive models. And linked to the data is really important now to go to the digital twins and to make this bridge between the physical and digital world. The idea of the digital twin is really to create a numerical or digital twin or double of the production site or of everything. One of the example I have clearly in my daily business is the building information modeling, perhaps far from the pure production site, but it's really the same spirit. The building information modeling is really to create a twin of infrastructures and to make some predictive or prescriptive model of what will happen, how I can be better, what will be the impact of this, I will say, information, or what will happen, and what is the idea is really to masterize what will happen in to make the predictive option and to see what will happen. And give you just at least one example, is linked to one of the also initiative flagship leading at the EPFL and from my faculty to create a digital twin on urban data platform of cities. And it's really the same message, and you can make a duplicate, and after it will be the presentation of Dimitris to explain it at the level of industries and production sites on manufacturing. But the idea there of the Blue City project is to create a digital twin of our cities and to make different digital twins of the mobility, the waste management, the energy consumption, the use of the circular economy of the raw material, local resource constraint. And through this, all the data collected in these different fields, we will create these digital twins, and we will be able to see and to predict what will be better for a better impact on the climate change from the city, a better air quality, a better traffic, and so on, to have these models from artificial intelligence, I will say, and to predict what will happen. So perhaps now I will let the floor to Dimitris to go further about what is digitalization, but the key message on my side is really digitalization are really opportunities. This new technology can help better and easier the industries to be more efficient and to tackle some big problems and to be more agile on the market. Thank you.
So much, Frédéric. Now the floor is open to Dimitris Kiritsis.
Can you give me the right to share my screen?
Yes, you can. Yes.
Not yet.
You can't share the screen yourself?
No, not yet. Not yet. So the share button is gray in my case.
Okay. Just give me a second.
Yeah. It says only meeting organizers and presenters can share. Yeah, it's okay.
Is it okay?
I think so. So let me find. Can you see my screen now?
Yes.
Yeah. Okay. So thank you, Fabien and Fred, also for the opportunity and the introduction to this webinar. So thank you also the participants to be here. I have the privilege to know some of you and met some of you in the past. So I will present you the current work that we do in my team on this concept of digital twins that we extend with cognitive capabilities, and we call it cognitive twins. So this is let's say a collaborative work in my team, and Dr. Xiaoshen Cheng is one of the key persons that contribute to this work. So for me, digital twins are enabling technologies that they integrate all elements of Industry 4.0 technologies with focus on data. And this enabling technology, what it enables the implementation of the concept of circular economy and circular manufacturing by allowing to collect all the data necessary, which are important to take decisions to optimize life cycles. So
I ask you to not to use your camera, because then the sound quality will be maybe better.
Is it better now?
Just your camera. Yes, yes. Maybe we will try. Yes, thank you.
Okay. Is it better now? Yeah. Okay. So yes. So the key is, let's focus in this presentation. So the key elements of digital twins, which is a kind of introduction to this concept of digital twins. So of course, the digital twins are twins of physical entities. So a digital twin is a representation of something which is physical and does something. In our domain of machine tools and manufacturing, these physical components are machines or installations or vehicles, all elements that we have, but also we can think about the digital twins of services also, and other aspects, humans. Some examples were presented by Fred before. So the first element of the digital twin is a virtual representation of the physical part of it. Then the data that are created or shared between digital twins or among digital twins. What are the services that can be implemented using this concept, and also connectivity elements. And let's go a little bit deeper to each one of them. So physical entities, as I said, are components or the product itself, or physical systems or processes. We can have digital twins of processes to fine-tune parameters of these processes, organizations also, even social organizations. So we can imagine digital twins of social organizations even. And we said in the beginning that the digital twin is permanently connected with its physical part, this physical twin. How it happens? It happens using sensors that generate data at the physical device, and Internet of Things technologies that they allow this data to be communicated to the virtual. So of course, this requires measurement technologies, metrology technologies, and also technologies about the data management, data collection, etc. So what we have in the virtual model, so of course we have representations or replicas. So sometimes they are so well done, so it is like in the movies, so you cannot recognize the physical from the virtual sometimes. And of course it produces the physical aspects like geometries, properties, colors, shadows, all that stuff. And also more intelligent elements of the physical thing, like behavior, how the physical part behaves according to some conditions, and apply some rules for the function, also at the virtual level. So to do that, so of course we use the advanced now, so the geometric models that including shapes, tolerances, important, very important in the machine tool sector. The topological aspects, the structural relations among these elements, etc. And behavioral models that they have to do with the transitions among or between states of the physical part. So, or the performance degradation. So, as we have a component, a motor, for example, an engine that let's say functions. So, and starts to create some vibrations. These vibrations can be also represented with a good precision in the virtual model as well, or sound, or temperatures, etc. And you have also the rules, so that allow the use of the digital twin to take decisions and improve the performance of the physical asset. So based on the what we observe in the virtual part of the digital twin, so we can apply on the fly some rules or some simulations, and this may create feedback to the physical part, so it improves its performance, avoid problems, etc. The data, of course, data are very important. So all this concept is data-driven. The digital twin concept, I mean. And here we may observe that we have various types of data are heterogeneous, so they can be captured in various times. So they are multi-temporal scale, multi-dimension, multi-source, and we have to deal with that. And we have to do with physical entity data, static attribute data, for example, or dynamic data that they change according to the condition and the function of the physical part. We have virtual data, for example, the results of simulations or of decision support systems that we may apply at the virtual part. And we have also service data. So when we call a service in the virtual world, so this can be executed also in the physical part. And of course, we can apply knowledge by rules of domain experts when we do decision making that we would like the physical part to obey to these decisions. And what type of digital twin services we are talking about here? So, so services that they are to satisfy requirements or specifications, such as verifications, monitoring, optimization, diagnosis, prognostic, and health management, like maintenance, which is a hot topic and the most popular application of data-driven techniques in the industrial world. And or supporting services, so use of particular data and algorithms, or other knowledge services, call, for example, look for some information on the internet, for example, to apply to a particular situation, or improve some software and deliver the service, etc. So these are the main elements that are implemented in the digital twin concept, connected to the physical world, and this has to be connected. And this connection has to be dynamic and almost real time, if we want, between all the entities that we have here. So we have connections, first of all, between the physical entities and the virtual models, the physical entities and the data, and the services, the virtual models and data, virtual models and services and data. So all possible connections can be possible and efficiently realized in this concept. So already you have many applications of digital twins by leaders in this domain. And also there are some companies like Dassault, Siemens, IBM that they sell digital twins. Also here you have to be careful, like it happens many years ago with when we lived the experience of the transition from CAM systems to PLM system. So everything was named PLM from one night to the other. So here some simulation systems are named the digital twins also by some vendors. And the main difference that you should be able to recognize here is that a digital twin should have a permanent connection with data coming from this physical twin. So it's not just a simulation. Of course, the virtual model, the simulation part is one of the more, let's say, important components, but it's not only that. And digital twin applications, they are implemented every day in a related pace in all domains that you may see here. So I mentioned the city domain, so in the construction industry, of course, a lot in manufacturing happens to optimize processes, in vessel industry also. At EPFL, there is a company, Axelos, that is doing that. So they observe, they have digital twin of ships, cargoes, etc., and they observe remotely their performance. Healthcare is a promising domain of digital twins. So, and soon I believe we will see digital twins of our bodies available to various actors to improve our health. And this flow here, so this workflow shows, let's say, an architecture of the system. What are the main elements to implement the digital twin models and how to use them? So you see the manufacturing domain. So you have a production when you have machines, logistics, assembly lines, etc. All these are creating data. These data are communicated to digital twins, and these digital twins are used to enable decisions, to enable monitoring, to enable performance, both in the design and the production, of course, and in the services. In the services domain, once you have here predictive maintenance and quality control, and I will give you later some examples of this. So this enabling technology, so what we do, so improves our capacity as humans to take decisions. And how we take decisions, so of course, first we see, so they have information, we learn from the situation, so we think by reasoning and to optimize decisions, and then we act. We do things by informing somebody or a system, or by acting on this system. So how we see by using sensors, for example, and various apps on the sensors. So how we think, reason, so we connect all these elements about the functioning of this motor, for example, that this digital twin allows to see the performance by visualizing by colored various parameters. So this allows us to reason automatically, if we can, by applying algorithms, or interactively by visualizing information, and then we act. So, for example, we apply maintenance, or we improve the design of an electronic component, for example, here, or we inform somebody else in the value chain to do something. So, Internet of Things, as we said before, is one of the basic elements that generated this concept of digital twins. Why? Because it allows to connect the physical part of the concept to the virtual part. By allowing on the physical part and using sensors to capture the data and communicating this data to the virtual part and back, of course, to elements of the physical asset when we need to act. So a digital twin may be actionable digital twin and allow actions to be happen on the physical. And as you see here, so we have three types of elements. So first of all, the sensors and other devices that can be used as sensors, virtual sensors, for example, ID parts, mainly wireless ID components like RFIDs, for example, and then the communication elements, various dimensions. So you can start with Bluetooth, Wi-Fi, 5G, and Internet connectivity technologies. And how we use all of this data that's collected and communicated to the Internet of Things. So we are using computers, either very close or on the machine. So this is the edge computing, or somewhere in the factory level. So here we have the fog level of computing, and then or we are using services on the cloud, like the ones mentioned before, Alibaba and all that stuff that maybe should not happen in clusters in local industry. But we use all these architectures that are also connected together and coordinated. And there are also on the software part, of course, software to manage the data. If you have a lot of data, you have to manage this data in terms of storage, sharing, etc. Take care of privacy and security. Blockchain technology was mentioned, for example, before. So you have various types of the databases, structural or non-structural. And on the data analytics, you have, let's say, mathematics, very good old mathematics like statistic analysis, and the more modern one like machine learning, neural networks, all these kind of techniques and reasoning techniques like prediction, etc. And of course, more and more natural language processing. This is happening. And as you see here in this table, so there is an assessment of what type of tools are available. Some of them are commercial, others are more open source, and more and more companies that are using open source solutions and tools to implement software applications for industry. And very important part is the visualization of data that allows decision making by humans. Visualization of data is very important. All this, what helps? So it helps what we do in all that such. So first, the first raw material is the data. And what we do when we take decisions, we transform the data. We do various levels of transformation of data to information, and data are meaningful. We try to capture the meaning of data in a given context. And if we transform it correctly, data in a given context becomes information. And based on this information, we may take decision. When we take decision, we learn. That means we give meaning to this information, which becomes knowledge for us. And with the time, this knowledge that we accumulate in our minds, in our groups, also social knowledge or corporate knowledge, becomes a kind of insight or wisdom for the community that is used for training, skilling, upskilling, and always new concept to improve the capacity of humans to perform. Basic technologies, so key technologies for to do this kind of transformation are the so-called semantic technologies that we research in my team since many years, it's almost 15 years now. And we use ontologies to do that. I will say a few words about that, and maybe the concept of knowledge graph that you may already know. And what it helps, this kind of semantic technologies, it helps by capturing the main entities of the real world. So here you see in this kind of graph, so these actually the ellipses here are entities, and all these entities of the real world are linked together with relationships. And this technique helps to link together data that are coming from various types of sources, either structured or unstructured. This is something very, very important because it allows existing legacy systems to work, to be used and work efficiently and effectively. So some examples of the use of this technology so far in my team in various types of projects. So as I said, so we started as something which is the market is requesting predictive maintenance. So it's the most, let's say, the application which is mostly demanded and used already. And what it implies, so it implies to observe a machine, how it performs when it produces data, to avoid creating defects on products, on the results, by analyzing data that can be captured in the machine. So here you see your Fisher machine, maybe all these kind of machines. This is a milling machine. And we applied, in this case, the architecture that you see here. So various heterogeneous sources of data, as you see, data management, so structuring of this data in form of semantics, ontologies, etc., and applying various types of tools. Identifizer is an open source tool to transform an ontology to a knowledge graph, for example, and then analytics of this knowledge graph by using various types of technologies to visualize data and decide, taking actions, calculating the remaining useful life, for example. And you see here examples of visualizing machining data that we capture from machines that allow to take some decisions according to the objective. The concept of zero defect manufacturing is also emerging, and it allows to observe, to measure data in the two main actors of the manufacturing process, the product itself, which is output of a process, of the machining process, let's say, and we are able, using metrology technologies and sensors, to capture data in various phases of the life cycle of the product. And at the same time, when we produce these parts, we observe the health status of the equipment, the machine. And in order to allow to the zero defect manufacturing, so the output of the process is the quality of the product. Measuring elements of quality at the product level and measuring elements of quality at the process level, correlating these two types of data using digital twin in the virtual world allows us to detect possible types of defects, if possible, repair them, predict by analyzing the data that we collect possible defects, and if we are able to predict, we can prevent them. And all these strategies of detection, prediction, possible repair, and prevention mainly contributes to go towards zero defect products and zero waste of the process. So we implemented this concept using metrology technology. So Dreyer is a metrology machine, and machining technologies, a milling provided by Jörg Fischer here. So in the case of producing a spindle that is used in this machine along the assembly steps or along the manufacturing steps of the spindle, we implemented that in this we call predictive manufacturing framework, where what we do, we collect data from the process, milling machines, CDM machines, for example, here, and the product, metrology inspection machines. We manage this data along their life cycle that are structured semantically using ontologies in what we call semantic framework. The output is the structured data in the form of a knowledge graph, and by applying appropriate algorithms using the digital twins, we can visualize the data so the humans can take decisions, or we apply decision support systems and algorithms to take decisions somehow automatically. This was implemented in Jörg Fischer with the help of other partners using the Microsoft platform Azure, which offers the possibility to structure the data in this semantic form. And so what we illustrate here is that we collect data that are collected during the production of the spindle in various types of forms, so PDFs, text, Excel, or direct data from machines, measuring machines and machine tools, or sensors. All of them are structured in semantic form and then analyzed, for example, using Power BI here, to be used by various actors, various stakeholders, R&D to improve the design, by customers, by production engineers, etc. Yeah, this illustrates, so I don't spend time, how on the spindle we have the data organized in this semantic form, and we use this measurement. So in Azure, we can illustrate, also visualize the graph. So in this spindle, which has a number, and you see here the number of all these parameters, measurement data are associated also about the spindle. Sorry. And this spindle is going to a machine when also has to do with cooling system or testing of the machine. And so this is to show that whatever we do in the spindle can be linked for further operations at another layer, the machine layer. This is the architecture of the Azure system as we use it. So using Azure Data Factory, for example, and Cosmos DB database is the form of the knowledge graph provided by Microsoft to structure semantically the data. So we implemented that. This is a first application, so this quality control app that we implemented at Georg Fischer, which here are the components of this spindle, for example, and by measuring the various parameters that you see in the columns of this kind of Excel sheet. So you see what are the green is that it works well according to the parameters. Yellow, we have to pay some attention, and when we have red colors, we see some problems from clients, for example, that they discovered something that has to be analyzed. And this was implemented using this kind of technologies. And in this small video, we have, so I will go in some kind of accelerated form. So we made an application for remaining useful life application. So in this machine tool, so the machine is cutting a workpiece, and we have a dashboard where we observe the various parameters of this type of particular machine. And this green color here says that we have still enough time for the machine and the tool and the spindle to work correctly, by observing also various types of measurements that we are able to do it. And here is what are the here now it became after some time yellow. That means that the time of doing something is approaching, and one maintenance is required. Then we arrive at the red level. So it's time to do an action, maintenance action, before something breaks, and allows to save and extend the life of this type of application. And some achievements you can see also here. The first type of achievements. So this is the concept of the what we call cognitive digital twin. But Kjausen, so you can open your microphone, and I would like to invite you to explain this to our audience, please. Kjausen?
Yeah, I'm here. Can you hear me?
Yes.
Yes, thanks. Well, previously, as Professor has just mentioned, I mean, the digital twins has been developing very fast in recent years in different sectors of the society, and especially for the industrial domain, we have the digital twins for different kind of products or systems, and these digital twins are corresponding to different part of a product, maybe, or sometimes they are corresponding to different life cycle phases. For example, for one aero engine here, for example, from the design phase, we have a series of models, or we call it twins here, from the CAD models, from the FEM models, and from the behavior models, etc. This is from the design phase, and later we will have much more, let's call it twins later during the production phase, and we will monitor the quality of the production and also the assembly lines, etc. And later we have the maintenance phase after this aero engine has been manufactured and delivered to the customer. And during the running phase, we will have another twin for the monitoring the performance of this engine. And even later, we will have the repair and recycling phase, etc. So, and during all this life cycle, we will have a lot of digital twins to create and to maintain. So how do we really connect them all together? So one possible way is to federate all these twins, or these digital twins, let's call it. So to federate them all together into one framework. So here on this figure on the right is an example of how to connect all these twins for the CAD models, for the FEM models, or later we will have the models of the assembly line and the models of the machine, etc. We connect all these models through using the semantic technology, using ontology, or even better with the knowledge graph. So that's all the connections between these different models can be identified and specified in this knowledge graph or ontology. So why do we need to do that? Because for the as indicated from the name of this concept, cognitive digital twins, we want the system or the twins to have the cognitive capability to some extent, to make decisions, to do the reasoning. Let's take an example. For during the design phase, we want to do some trade-off. Maybe for the assembly line, you have to take the quality into consideration, take the cost into consideration. And when you change one factor, how does this factor affect the others? If you are using only one digital twin, you can identify the impact of this change inside this one model, but how does this change will impact other models? In that case, you have to integrate all these models together into one framework and identify their interconnections. And if we go even higher level, from the design phase to the manufacturing phase to the maintenance phase. So, for example, during the running of this aero engine, we found a defect. How do we trace back the root cause of this defect? Currently, we might need to involve expert from the design, from the manufacturing, all these phases. But in future, if we can integrate all this information into one framework, maybe the system can tell us automatically how this defect is produced, because all the information since the early stage of the life cycle of this product has been included in this framework. So basically, it's kind of the concept of cognitive twins is kind of like enhanced version of the current isolated twins. So we federate all these twins together and to produce more services and more advanced and cognitive applications. So the main technology for that from our side is mainly focusing on the ontology and the semantic modeling, and also the product lifecycle management, the PLM systems. So we can organize and integrate all different information and data corresponding to different lifecycle phases of the product. So, but this is the general idea of these cognitive twins. So, of course, we will have more following research and experiments on this concept.
Thank you. Thank you, Klaus.
May I please ask you to come to a conclusion so that we can open the floor for the discussion and the questions?
This is the conclusion, Fabian. Thank you.
Thank you.
Yeah, as you understand, all this concept of digital twins and more the thing that is coming, the cognitive twins that will be realized, not very far from today. Elements are already realized. So this requires data to be shared among stakeholders. So now there is a kind of retention to share data among partners and among factories, but this will be the role in the near future. And I would like to encourage you to read this first report of the World Economic Forum about the value of sharing data and how to unlock this value of sharing data for management. Thank you very much. And I stop presenting now. And we are back to the meeting. Thank you.
Thank you very much to all of you, all the three speakers, for your inputs, for your presentation. I would like to hand over directly to the audience. If you have questions, please raise your hand or unmute your microphone to ask the questions. In the meantime, I would like to ask the first question. You showed us the example of the Georg Fischer collaboration you had earlier. We are especially in contact with small and medium-sized enterprises, which are very hands-on. They have not the same resources, of course, like Georg Fischer. Can you indicate, on the one hand, what was the dimension of the project, time-wise, but also budget-wise, to do this development and implementation for Georg Fischer? And on the second hand, what would be a reasonable start for a small and medium-sized enterprise to start with a first project in the field of digital twins and cognitive digital twins?
So in the case with Georg Fischer, so we work together in a couple of since years. So in European projects funded by European Union, and some of them, so they include more than 10 partners with total budget of more than 5 million. Some of them go 10 million, and the part of us for us and Georg Fischer is around 1 million for both of us for a period of 3 years. So these are collaborative projects, including many, let's say, European partners. They have a strong administrative burden, if you want, also for small industries, but we know how to do it. We support them. We supported also Georg Fischer at thing. And currently we're involved in 2 projects where we implement this kind of digital twins. Again, them also are European funded projects, but particularly for SMEs, I would like to go with small scale examples using with the InnoSwiss projects. Small scale examples. When they have the opportunity and if they have some resources, some expert to assign to a bigger scale project, a European, let's say, funded project or other type of project, then it will be a good experience. But they would need the support of a research organization to help them or coaches like you to help them to do this kind of things. Also, we have the EU Research Office in Bern that may help a lot SMEs to link or to integrate this bigger consortia to do larger scale projects. And also the timeline. So in European project is 3 years minimum. So you should see what you expect to have in the future and the kind of driver, not a follower. So for shorter term, let's say smaller scale applications, I think the InnoSwiss model is more appropriate.
Okay, thank you. So I see we have a first question from Emma. Can I please ask you to ask your question?
My name is Emanuel Reuter. I am an assistant professor of innovation management at the University of Neuchâtel, and I'm particularly interested at the interface between technology and managerial decision making. And so, of course, your notion of digital twins and cognitive digital twins is interesting to see how technology can enable managerial decision making. And I was wondering whether there's actually a lot of research. So I did a small research on my side, but I'm not an expert in this. But is there research at the technology human interface and how this notion of digital twins, cognitive digital twins, actually enables human decision making? So in the managerial literature, we don't have such things yet. I see a huge opportunity there, but is there something more in the larger literature, perhaps, and research on human-computer interaction or human-technology interaction?
Yes, of course. So in the current work program, if you look at the work programs of the European Commission, so the new program focuses on human aspects. So there is a batch of topicals that have the keyword human inside. And there is another batch of topicals that they have the twin inside. So both of them, they try to illustrate for the need to have this human-machine interaction from various points of view. So in the past, there were topicals and projects with results for the human-computer ACI, human-computer interaction, and let's say interface on the technical part, how we design interfaces on the machine for a good human interaction. So now the research goes deeper to the cognitive aspects, how we allow or we implement collaboration between humans and machines, not just the interface, the technical interface, but also the real collaboration between a human and a machine, or human and more machines, or all that stuff. So maybe you know also the notion of cobot, collaborative robot which is able to collaborate with a human, which is also a research. You have prototypes of this kind of robots, but it is still under development. So there are research topics that are there. So we are not experts in that, so we do not do. We are more technology guys.
Thank you very much. Very interesting.
You're welcome. But have a look at the last work program of the Horizon Europe. You will see a lot of things.
Any more questions from the audience? I have one more question. I come back to the example of Georg Fischer. Is there an evolution of the project? Let's say that they changed also the business model based on the work they did with you. Do you see some signs in this?
Yes, of course. So they realize the need of sharing of data. Because Georg Fischer, as Tornos, I believe, so they produce the machines, but the real experts of using the machines are their clients, and the real producers of data with their own machines are their clients. So in order for Georg Fischer or Tornos, I believe, to implement a real and efficient predictive maintenance service, so they have to have access to the data produced by their machines when they are at the client place. So they have to change business model, to make agreements with their clients, to trust them to share their data. Why? Because the clients, the user of the Georg Fischer machine, so they use the machine in the way that they know, and they are afraid that if they share their data, Georg Fischer will be using their own data to sell services to their competitors. And so it is this whole, let's say, problem of sharing data and how to get value from this. And Georg Fischer, they want to implement predictive maintenance solutions, good ones for their clients, and they want to go more and more to services. This is the trend.
Thank you.
What does it mean service? For example, using by hour, by volume of cutting, or I don't know. There are some people they are starting using this for other type of machines. For example, Atlas Copco, they don't sell the machines. They say they sell pressed air, volumes of pressed air, and the machine remains them. But in the machining domain, let's say highly sophisticated machines like Tornos or Georg Fischer is more difficult to design the service than it was. And what I know also that Georg Fischer, they want also that they say they want beyond machines, and what they want to sell is machining solutions for manufacturing solutions, including many types of machines, not only a milling machine or whatever.
Yes, thank you. I see a second question from Emmanuel Reuter. Emmanuel, please.
Oh, sorry, this has been a mistake then.
Remaining.
Yes.
Any other question from the audience? The last moment to ask a question. No, then with this, I would like to thank the presenters very, very much. That was great to have your inputs and your insights about digital cognitive twins. I would like also to thank the audience to be present with us today for this webinar. We will make available the video on our website. And with this, I remain to wish you a nice summer, and we see us in August again. Have a good time. Thank you for joining us. Bye-bye.
Thank you. Enjoy the summer. Bye-bye.
Thank you for coming. Thank you.
Bye.
Bye.
Thank you. Bye.
Thank you. Goodbye.
Bye-bye.
Top.